Cool. All right. Tēnā koutou katoa, ko Matt Boucher, Tucker Wingwa. I am Deputy Principal of Raroa Normal Intermediate School. I have taught at different ages at different times, done lots of teachings of science. I've taught year 12 and 13 Earth and Space Science at different times. I'm a past president of the Wellington Astronomical Society, and I've been involved in space stuff for quite a while. I've been asked to come in today to speak to you a little bit about Matariki. So here we are with the reason for the season and what's coming up.
That might not be connected.
Okay. I'll just do that. We'll start with a quick karakia. Feel free to follow along, otherwise I'll do my best at it. Manawa Maya te putanga o Matariki. Manawa Maya te ariki o te rangi. Manawa Maya te matahi o te to. Hail the rise of Matariki. Hail the Lord of the Sky, and hail the new year. When I started doing this talk, because I've done this for quite a few years now, it was before Matariki was a public holiday, and it's been really cool to see it come into its own and become something that's really part of the DNA of New Zealand, and get a day off for it, so bonus. As we go through with Matariki, I want to take it from a couple of different angles. So I'll start with talking about the star cluster itself. So let's do the astronomy. What are we actually looking at? What is all that about? A little bit about around the world, because it actually is quite an important star cluster and a marker of different times of the year around the world. Obviously, looking back at home here to Maori and Aotearoa, the importance of the season and why it's such an important holiday here. And then we'll have a little bit of a look at how you can spot it in the dawn sky and play a little bit with stellarium and show you what is happening up there. So to start with Matariki, the star cluster. So you'll have seen these beautiful shiny blue stars out there. Again, a lot of the colors come through the more we tend to magnify and can see that. But it is overwhelmingly blue in color, unlike some of the star clusters that Adam just showed you, where you can see a lot of different colors of stars in there. And there's reasons for that, which I'll show you shortly as well. But first, we're looking at those big baby blues. So B-type stars, looking on, this is the main sequence of stars here. So we're looking along this stripe. This is stars doing their core business, right? Burning hydrogen into helium, having that nuclear fusion going on before they start dying and freaky things happen and they become supergiants and they become white dwarfs and all the different, supernovas and things take place. So when they're just, in their youth and in their middle age and they're burning away, that's all that different colors of stars that you get there. And if you haven't, a lot of people aren't aware that there are even the different colors of stars because you often have to magnify to see them. They just look white in the sky. But it does tell you something when you see those colors. I often explain it to kids as it's like a flame, right? When you have a flame on your burner, gas burner at home, the hotter parts is the blue, the cooler tends to be your yellows and your oranges and out to your reds. And in this case, that holds true. So the blues are burning hotter. And part of that is because they are much bigger, right? So much bigger stars, lots more fusion happening at any given time, burning away, giving that really hot surface temperature. And that's why you're getting that blue light. Unfortunately, even though they're so big and burning away, it means they live fast and die hard. So they are burning through their fuel very quickly, burning very hot, and they're going to run out of gas a lot quicker than other stars, which means seeing the different colors within a star cluster like Matariki gives us some interesting information about its age as well. So this is showing you the formation of a star cluster in the first place. So you get a big ball of gas and dust out in the universe floating around. Usually things left over from former stars that have exploded, supernova, or turned into red giants and shed their atmosphere. So as that gas and dust is floating around, it eventually starts to come together and starts to clump together. We get that kind of friction effect almost of gravity pulling it all together, things starting to get hotter as it starts to collapse. And it becomes that in local regions within that bigger cloud, you get lots of little stars being born within that, and that's the birth of a star cluster. Now, as those start to form, lots of different kinds of stars are formed, big ones, little ones, goofy ones, all the different kinds of stars you can imagine within that star cluster. But when you're looking at that young star cluster when it happens, so those stars light up, most of the gas and dust that's still left over either gets sucked into some of those stars or blown away by the solar wind. That young cluster, when you're looking at it, looks very blue because the blue ones are the bright ones And all the other ones are in there, the yellows and the reds and all of that, but they're outshone by their big brothers and sisters. So over time, when those guys then start to die young, they burn out a lot quicker, then you start to see some more of those colors come through. Those little red ones that are burning a lot less hot, some of them have lasted us as long as the known universe that we have. It's billions and tens and billions of years, whereas some of the blues, a mere few 100 million years. Yeah, don't get very far. But it means that when you're looking at some of those clusters, like the ones Adam pointed out, and you're seeing the reds coming through, and you're maybe seeing some greens, you're seeing some different things happening, it's an older cluster. Because all the clusters have it. Matariki's got all those guys too. You just don't see them because the big blues are outshining them, right? So a young cluster is Matariki. Only 100 million years old. It's an infant. Tiny little guy. Here's some baby pictures. Now I've cheated and I've used the Orion Nebula here because it gives you an idea. That's one of the easier nebulas for us to see in small telescopes. It gives you an idea of what this would have looked like just 100 million years ago. And that's all those clouds of gas and dust out there. And you can see, if you're looking in the Orion Nebula, even with a small telescope, you get that cool cloudy effect going on, but you can see within it little guys, little baby stars being formed right there before your eyes, which is pretty cool to see. So that's what it would have looked like within its formation before all of that got collapsed into stars, like these newborns here, and then eventually what was left blown away. A little bit on what we're calling things. I've been referring to it as a star cluster. That is not to be confused with a constellation or an asterism. It is a cluster itself. So the difference here is that when you're seeing a constellation up in the sky, you might see a couple of stars that look really close to you together, even just adjacent to each other in the sky. But one could be, a couple 100 million light years away farther back than the other. It appears to you from your perspective to be quite close. And those patterns we see in the sky we call constellations. So a bunch of stars, like this is a good example of looking at the distance within Orion. Stars that seem right next to each other might be nowhere near each other. It's just convenient for us to figure out where in the sky that is. And an asterism is something that isn't an official constellation, but it's kind of the same thing. It's just a pattern of stars like the pot. Oh, there we go, upside down here. The pot, all right? Not an official constellation, part of the constellation, but it's a pattern that we're used to seeing. So we call that an asterism. Whereas a cluster, in fact, we're all born together and are all close together. Kind of. Just like saying that the Matariki star cluster is quite young, because it's only 100 million years old. Just like saying, hey, they're quite close together. Like from one side of that cluster to the other is only 43 light years. If we're looking at our distance between Earth and Matariki, that's 444 light years. Again, I know many of you are probably very aware of this, but I'm always marveling at those big distances and the fact that we can judge that by how far light has traveled. Because when you're looking at it, 444 light years distant, that light left that star cluster 444 years ago, and we're seeing it 444 years in the past. So often, I love the observational science of astronomy, because when people ask things like, how do we know what happened in the past? You go, because we can look at it, it's over there. Because the light is still traveling from that time. But yeah, from one side of the cluster to the other is 43 light years, which is small compared to that 444 light years between us and it, but is quite big compared to the 4.2 light years. It's almost powers of 10 here, isn't it? Between us and our closest star. So if we were sitting right now in the middle of the Matariki star cluster, we would have no idea we were in a star cluster, really, because some of those stars wouldn't be any closer to us than we are to our local stars. You'd have to be 444 light years away to go, oh yeah, they're all part of the same clump. And you notice it's shiny, right? Kind of nice. We, for a very long time, when you look at a lot of kind of shiny star clusters, there's different reasons for that. And one thing we thought for a long time about Matariki or the Pleiades was that was a lot of like leftover gas and dust that hadn't quite blown away or hadn't quite been sucked up by the stars that were formed within it. That kind of tracked too, because it's such a young star cluster that there could be stuff hanging around. Upon further investigation, though, it turns out that's not the case at all. It's more complicated. It's called a reflection nebula. So if we're looking from Earth, right? What we're actually seeing is, so you've got here Matariki, right? That star cluster shining away. And of course, it's in 3D space. So we're seeing one side of it shining at us, but the other side shining in the other direction as well. And what we're able to determine is that what's actually happening is that the light that's shining away from us is going all the way back to a big reflection nebula. So basically a shiny mirror-like, cloud of gas and dust. The light's bouncing off that and then bouncing back and hitting us. So I don't know the numbers to it, but the shine, if we're looking at distance and light years and age of it, the shine is many years older than the light from the stars itself because it's traveled some distance and then bounced on back. Kind of cool. Right, so that's the stars. So what about some of the significance? Let's do a little tour around the world. It's been known for a very long time. I mean, it's very rare that we have a star cluster that's that distinct and that you can see with the naked eye. Right, so in prehistory, even binoculars were not a thing. So being able to see Matariki, especially because we had the advantage of having dark skies, unless you had really shiny torches, meant that you could see that star cluster and it's very distinct in the sky. So a lot of cultures noticed that. And this is from the Nebra sky disk. This is from Germany, approximately 1600 BC. So long time ago. And it's believed that this represents the Pleiades or Matariki. Ancient Greece recognized that. That's where the name Pleiades comes from. And often, because of the pattern that we'll look at later of, and that you've noticed that it's in the sky for most of the time, disappears for a few months and then comes back. Now is the time we get the most interest in it because when it disappears, that period where you can't see it in the sky and then it comes back for us, often it's when people want to see it the most. And I have to explain that Matariki is by far the worst time to look at Matariki because 6 months from now, you'll see it a lot more clearly. But that's a way of marking time, which is, the big clock in the sky has been astronomy. So the Pleiades comes from plane or to sail. And its reappearance in Greece was the symbol of now the sailing season has begun once again. So again, noticing that pattern of, okay, it's gone, wait for it, sailing time. So that's plane or to sailing for the Pleiades. And a lot of it then gets wrapped into mythology, like most of the constellations and things that we have are telling stories in order to remember those patterns, in order to act upon them. And so the seven sisters are the daughters of Pleione, the sea nymph, is part of how that name comes about as well, and worked into oral storytelling so you can remember when it's time to jump on the boat. Subaru, that's Matariki, which I didn't know that till after I bought one, and then I was super chuffed. So very well known again. So you'll see in Japan, it's very well known as a star cluster. In India, it's called Kritika, the 6 Kritikas. So often the number of stars that different cultures think they can see with the naked eye differs. There's 7, there's 9, there's 6. It's the same cluster. It's just what you reckon you can see, right? And there can be different visibilities in different places. But the reality is there's hundreds and hundreds and hundreds. So it's, how good are your eyes and how good's your telescope is the answer. The 6 Kritikas who raise the Hindu god Karkeya, and that's their names, which I won't attempt to pronounce. But again, it was worked into mythology as being often those sisters or some kind of siblings was the vibe, because there they are, they're all right together. And it's accurate, actually, because they're all born from that same nebula. So that's pretty cool. In China, I really like this one. So this is Maoshu, the hairy head of the white tiger of the West. And it's so the Matariki is the head of that constellation, the white tiger, and that it's the hairy head I really like because it's got that fuzziness to it. So that's kind of cute. I like that. In Australia, Kautagurk, the 7 sisters who held fire in the ends of sticks in the dream time. That's the origin of fire. Again, worked in there, same star cluster. Here we got 7, again, sisters. So we have that whole siblings thing worked in once again. Hawaii, so again, a very similar culture that to Maui, so part of Polynesian. So Makaliki begins the Makahiki season and the new year, and again tells you different things as far as what that means for planting and sailing and all of that, because of very different latitude. but the same idea that it's marking time and marking seasons of the year. All right, so let's bring it on home. Matariki to Maori and Aotearoa. So first of all, I'll give credit where credit's due. I didn't make this up. I haven't done extensive research on my own. That's your guy, Rangi Matamua, winner of the Prime Minister's Science Prize, one of the founders of the Society of Maori Astronomy, Research and Traditions, and the author of this fantastic book, Matariki, the Star of the Year, which basically everything I'm about to say is based upon. Highly recommended if you haven't read it. Fantastic stuff. And so much more detail than I can give you here as well. So we'll look at, I think it's cut off on the top there, but it's the Maramataka. So the traditional Maori calendar of the year is a lunar calendar. And so it's going year on year, month on month, looking at the cycles on the moon. And so this explains part of why Matariki is at a different time every year, just like Easter and other holidays that are based upon a lunar calendar. But basically, we have the year separated into 4 seasons, and looking at a separation of several months within each of those, or periods of time. So when we're looking at Matariki, we're looking at the start of Takarua, so the beginning of winter, and into the Tangaroa period of the moon. We'll look at that in a moment as well. But it's marking, the fact that Matariki is happening just around the winter solstice is no coincidence as well, that we're looking at this is the true winter time. And that's marking those seasons. So what does that mean for marking the new year? So it makes sense to have that be the new year, just as in the Northern Hemisphere, start of the year was near the darkest time as well. So looking at the start of January or around the solstice in late December, we're looking at the opposite here around late June, early July, marking that solstice and start. So it's the end of the harvest. So if by Matariki time you haven't got the crops in, too late, my friend. Needed to all get in by that time. And we're marking the end of that harvest time. All the food has come in. It's all being stored in things like the pataka kai. Keep it for the winter and to keep everybody going until the next time food is more plentiful. Also marks a time to gather certain species, right? Like this tasty treat over here that we're not allowed to eat, but man, that'd be good. This is different times of year, both for their abundance and for just marking out over the course of the year, when do you eat each species? Because if you chow down all the time, we're going to run out of them, right? So some of that kind of conservation is built in there as well, of having set seasons that's the time to catch them, other seasons where it's time to leave them be. Again, that whole cultural idea that's happened across the world at the darkest time of the year and the coldest time of the year is lighting up the darkness, right? So it's a time where it's the new year, but it's a time for celebrating, remembering the past, planning for the future. Things like lights, I know things like fireworks have been controversial in the past, but it actually fits with that idea of light in the dark, right? So lots of fires, lots of celebration, lots of food, like most harvest festivals. That's what's happening at Matariki. Now, a bit about the story of Matariki and where that name comes from in traditional Maori legend is it's short for Te Mata o Te Ariki Tawhirimatia, the eyes of the god Tawhirimatia. So the idea is that Tawhirimatia, who's well known to Wellington, he's the god of the atua of the wind, cranky dude. When in the beginning, when all of the brothers and sisters of Ranginui and Papatuanuku pushed them apart, led by Tane, to make the space in the world so we can all live and let the light in, Tawhirimatia didn't want that to happen. He was on the opposing team. There was an argument about what we were going to do, and Tawhirimatia was not keen on that happening, but it went ahead anyway. He wanted to be up with his father. There he is, up in the sky still. Didn't want his father to be separated and pushed away. But again, lost the vote, and it happened. Didn't just go with that, though. He kind of had an epic tantrum. So in his big rage about what had happened, he actually tore out his eyes, stomped on them, and threw them up into the sky. So, heck of a tantrum. And those broken up pieces of his eyes are what formed the Matariki star cluster in one interpretation, in one iwi, because there's many, many stories related to this, right? Now that means that Tawhirimatia is a blind god, and so he has to feel through the world tactilely. And so when your hair's blowing around and your roof is threatening to come off, he knows where you're at, but he's figuring it out the hard way, right? So the 9 stars of Matariki, Te Iwa o Matariki. Again, some cultures 9, some 6, some 7. It just depends how many you think that you can see. But traditionally, it was the 9 stars of Matariki, and that was Matariki herself, one of the stars, and her 8 children by Rehua or Antares. Now, Rehua, Antares, which we saw was also being in conjunction. Sorry, give me the word again. When it's going behind occultations. When Rehua or Antares is being occulted by the moon, so we're talking about that, and that's in the constellation of Scorpio or the fishhook of Maui. Well, I won't go on this big long rant about it right now, but Rehua is very important to Aotearoa because different islands within the Pacific have what's called the zenith star. So at certain conditions, certain time of year, that star passes directly overhead. And that's one of the ways that you use in Pacific navigation to find those different islands. So every island has a star that's particularly attached to it. The North Island, Te Ika a Maui, ours is Rehua and Antares. So it's quite an important one. I will have that rant. So that's part of the fish hook, yeah? And you've heard of like Maui fishing up the North Island. So if you're in the Pacific and you keep going towards the fish hook and the hook gets higher and higher and higher, eventually, boom, there's the North Island. So it's that idea of fishing up the North Island is actually directions on how to get here. So Rehua is very important. That's Dad, Matariki's mom, and here's the kids. Each of them has a name, and each of them has a significance, right? And that significance was the early prediction. So when Matariki first rises in the sky after its period of absence from the sky, and you're looking up, and you'd be out on the hill waiting to get the first sighting of it, that's when predictions for the year were made based upon what's going on with each individual star. Is it a little brighter today? Does that one seem a little harder to see? Does that one twinkling extra? And the significance of the stars and what they're related to would come into account there to make predictions for the year. Are we going to have a good harvest? Is the hunting going to be good? Are we going to have issues with our health within the family? Those are different things that they would look out for to make those predictions. So there's Matariki herself, mom, and her significance is about the health and the well-being of the people for the year. So again, really bright, good sign, maybe a little dim, maybe a little more harder to see. Not sure. I have to make some complicated predictions based upon that. Paul Hutakawa is about death and the dead. YT, fresh water and its food. YTA, salt water and its food. And this is interesting too. If you look at the positioning of them, YT, fresh water, is above YTA, salt water, as it is on Earth. Yes? Waipuna Arangi, the rain, nice up high. Tupuanuku, food grown in the earth, down low. Tupuarangi, food from the trees, above the ground. Again, some of that has some significance of what the placement is. Rangi, about the winds. We get that very bright in Wellington. And Hiwa Iterangi, which is wishes for the coming year. So that's kind of your wishing star. If you're going to wish upon a star, Hiwa Iterangi is your star to do that. And again, looking at their positions, looking at their brightness, and that gives you a little bit. That was how predictions were made for the coming year. So Matariki, sitting here, is part of the bigger constellation. Sorry, that's a little bit blurry. Of Te Waka Orangi. Right. So again, when we're looking at constellations, we're just drawing pictures in the sky, right? So different cultures have different ways of doing that. It only makes sense that to Maori, the Waka was such an important constellation. So Matariki is here on the prow. And as we go back, you can see some more familiar friends. You can see things like here is the pot, yeah, as part of Orion and other stars within there as well. I'll show you a comparison in a moment. Again, looking at the Waka. Didn't always have a smoke-free sign on it. Again, a comparison, that's a screenshot off of Stellarium compared to the picture of the constellation. You can see how those stars line up. Interestingly as well, you could see Rigel here, or Puanga, was used by other tribes, particularly up north, in place of Matariki to look for the new year, because the difference in latitude meant that it appeared and disappeared around the same time that Matariki would for much of the rest of the country. So, part of the tradition, the annual tradition of it, is about mourning the dead. So, in the new year, looking at back at who has passed during the year. And then the tradition of 1 year after death. So if we look at back here, the stern of the ship, right? And you can see where we have the pot or Orion, and then this kind of trail coming off here. Now, a couple of those are stars. A lot of that is stylized. And that represents kind of what you can see here on the prow of the kind of flowers hanging off the end, which is kind of honoring the dead for the year. Now, the idea is that the waka goes across the sky all year long with Matariki at the prow. We'll look at how that appears and disappears a little bit on the planetarium software. As it goes across the sky all year long, it is collecting the souls of all who have died that year and hanging them like little feathers, little flowers off the back of the waka. So carrying their souls along for the year. The next year, then it disappears, right? As it disappears into the spirit world for a period of time, and then reappears at Matariki time. Now, all of those souls have been taken to the spirit world, and in the next year, as the waka makes its next trip, all those souls are released into the sky along the journey 1 year later after their death as new stars. It's a tradition. And so a lot of that is built in then that often Maori will have, a tangi, a funeral, and then a year later to come back and have like an unveiling. There's often like a 1 year later ceremony, and a lot of that is related to those traditions. Again, I'm generalizing here because there's so many different interplays of different iwi, but that's what I've learned from the good doctor. All right, so a little bit about seeing Matariki in the dawn sky. This is actually us viewing it up on Mount Vic some years ago with the Wellington Astronomical Society. There's my son just in the corner there. Yes. Just a little guy down here. All right. So now you see it, now you don't. How come it disappears? Well, I mean, spoiler alert, it doesn't. It's just that we can't see it, right? So as we look and we're tracking across the year and the Earth is going around the sun, you're just looking at where the angle is that you can see Matariki. So Matariki is sitting over here past Taurus. Other times of the year you can see it, and it's either farther or closer to the sun. So if you're looking 6 months from now, like in December, the nighttime of the Earth is that way. So it's up all night, gets nice and high. As you come around to here, you're kind of seeing it more at an angle, right? A little bit closer to the sun. And it gets closer and closer to the sun in the evening until eventually sun swallows it. So it's behind the sun, you can't see it anymore, right? We continue our journey. Oh, yep, still can't see it, till you come around here, and then early in the morning, boom, you're able to catch sight of it. So it's just about purely that angle and where the sun is. If we turn the sun off, you just see it all the time. But that'd be bad for other reasons. So looking at Matariki dates, its setting and its rise and the period that we consider the Matariki period. You can see it's always roughly around the same time of year. The reason why it drifts around is because we're looking at not just when it's actually visible, which tends to be very much the same time of year, but also looking at when the period is considered, and that's looking at when the new moon or the Tangaroa period is happening. So yeah, there is a lunar calendar aspect to that. It's always around that same time of year, but looking at when it's new moon so that it's most visible and most able to be seen early in the morning. So for a couple of shots here, this was mid-April. And you can see this is in the evening. So we're looking at 6:45 p.m., April 11th, just because that's when I can get a good little picture there. You can see the waka. So the waka is currently taking a nosedive into the horizon. And over the course of the year, it does that. So you have some times where it's kind of very flatter along the horizon, other times where it seems quite angled. And as it's going to disappear, it kind of comes up, and over the course of the night and going into the morning, into the evening, it seems more and more angled and eventually starts to sink down. And so you're seeing it is actually making that little bit of a nosedive. There's Matariki itself on the prow, going back to the rest of the waka, and up here is the stern with the feathers hanging off and all of that going down into it. So that is mid-April. If we fast forward to 5:30 a.m. just before dawn, 3 months later in July, boom, the whole thing pops up over the horizon, and it's quite flat on the horizon. So just before dawn, and you can see there's the waka in the orientation that I was showing you before. Matariki over here, all the way back to the end of the waka, here to the stern. All right? So it has that kind of nosedive away into the spirit world and kind of pops up on the horizon. And there's a bit of poetry to that as well, because when you're actually seeing ships coming from across the horizon, it does seem to do that. I mean, you'd see the sails slightly first if it's a little bit taller, but then it all kind of, there it is on the water, right? So it's come back from the horizon, come back from the spirit world. So we'll have a little bit of a muck around with the planetarium, and then I will attempt any questions as best I can. I'll just show you a few little bits and bobs about how things are moving as we come up to Matariki. Here we go. Okay. So let me just get the date and time up here. So if we go again back in time a little bit, we'll go roughly to where I was looking before, 11th or so of April, because that's where you can see it quite clearly. Looking to the northern horizon. Where are we? Here we are. Even a little bit earlier than that. Like me. Okay. There we are all the way through, and Matariki, where's the Pleiades? Will be just down here somewhere. There we go. That's the end of March. But this is 8 p.m., 8:30 p.m. You can see that. A little bit earlier in the night. You can see it a little bit closer. But again, you're getting the idea. That's when the sun is starting to set. Matariki itself is quite low on the horizon. And there's the rest of the waka there. Now, as we go day on day, looking at the same time of night, so let's go a little bit later so we don't. If you go earlier in the year, it's higher and higher, right? And as you get later on, every night, this is one day after another, just that little bit farther down, little bit farther down. All right, if you're up on a hill, you can see it a little bit better, but eventually it disappears. The whole waka goes and sinks down, and it's gone. So you get to, around now. Oh, well, what are we in June now? You might just be able to see the stern of the waka as it descends at the beginning of the night, but it's gone, right? The waka has gone. So we fast forward to July and looking at that same area of the sky of the evening, and it's nowhere even close. Where's the thing gone? Oh. Well, now it's in the morning. So we'll fast forward. Too far. There you go, 6:15 in the morning. Spin around. See if we can spot it. Where are we? There's the whole waka. Again, if we go, so you see it here, we got Matariki here. Ooh, I don't even know how I did that. That's cool. And over to the stern of the waka here. And again, if we look, each day, it's a little bit lower. This is at 6:15 in the morning. But again, you can see that effect. So if you're out at 6:15 in the morning in a couple weeks' time, the 13th of June, no sign of it. See Rigel coming up, Puanga. A few days later, bang, whole thing up on the horizon, just like it's come over the water back to us. All right.
Mars pointed out quite nicely.
Yeah. Right. And that's what I have to share with you tonight. So happy to attempt any questions if you were to have any. I hope that gave you a little bit more insight into Matariki.